Welcome to another lecture of digital electronics. So today I am going to discuss register in general. So you already know that the flip-flops are the essential component in clock sequential circuit. So flip-flop basically store 1-bit data, and it is a 1-bit data storage element, right? So, and it is synchronous with clock, and it can store either a 1 or 0, right? So this is a basic thing about flip-flop that you already know. So basically circuits that include flip-flops are usually classified by the function they perform, right? And two basic application of flip-flops are mainly the counter that we already discussed, and another thing that I am going to discuss today is the register. So register is basically the data storage element, and it is basically flip-flop is a n-bit register, or n-bit register is basically consists of a group of n flip-flops capable of storing n bits of binary information. Okay, so this is an example of a 4-bit register. So it can store 4-bit data, and so it is a collection of four D flip-flops. So D flip-flop means data storage flip-flop. Okay, so you can see that all these flip-flops are triggered by a same clock. So they are working in a synchronous fashion. Okay, so and they have different D input. Okay, so PD, PC, PB and PA. So these are all 4-bit parallel data input, and we can have 4-bit parallel data output, right? So this way, so if it is a positive age triggered flip-flop, then when the clock will be positively age triggered, then this information, this PD, PC, PB and PA will be stored within these flip-flops, and at the same time you can read out this information through their output unit, right? And so in broadcast definition, a register consists of a group of flip-flops and gates that affect their transition, right? And the flip-flops holds the binary information, and the gates determine how the information is transferred into the register, right? And so, and in the similar way, you can also treat, or you can consider counter as a special type of register. If you remember the counter, then you can see that a counter is basically also a combination of flip-flops that goes through a predefined sequence of states, right? Right, so in that way you can also treat counter also as a register, because there is a collection of flip-flops, and but there they flip through a different states that is predefined, right, by the designer. But in register, usually what we will do is that we will so let's represent this schematic diagram. So this schematic diagram of this format in more concise way. So I will just represent the same thing using this format, that is so these are all D flip-flops. So 1, 2, 3, 4 D flip-flops, and they are parallel input D1, D2, D3, D4 and parallel output Q1, Q2, Q3, Q4. And you can see this clock is connected to this register. So it is not shown internally, but this same clock is connected to all the flip-flops just like here. Okay, so this is the same thing. So this is synchronous operation, so synchronously connected all the flip-flops. And apart from, so one thing, suppose at any time 0101 is stored in this register. Okay, so if clock is high, then this D1, D2 and D3, D4 will be stored in this 4 flip-flops, and that will be also can be read from Q through their outputs, right? So if its clock is high, So, but we don't want this type of operation. We don't this type of operation where we don't have any control over the storage loading of the flip flops. Okay, so we need another input. We will control the bits the data storage in register. So how we can control that? We can control it by using other one input, that is called load input. So this is also a active high input, and the use for why we are using this load input. So if it is 1, then at the next clock cycle the clock will be the data will be transferred to this register. Otherwise the same data, if load is 0, then the register will retain the same data. So that it will retain 0101. It will not goes to another states through the data input, that is D1, D2, D3, D4, but it will retain to the previous state only, that is 0101 if load is 0. So if load is 1, then the next clock cycle, the next clock edge, suppose positive edge, the D1, D2, D4 will be transferred to the register. Okay, so this way we can control the register operation, loading operation, right? So clock triggers all flip flops on the positive edge of each pulse, suppose, and clear is similarly the clear input is used, which is also active high input here. So clear is useful for clearing the register to all zeros prior to its clocked operation. Okay, so usually it works as asynchronously. So it is independent of clock. If any time clear becomes 1, then all the flip flops will be cleared or reset and recessed. Okay. So for synchronization, it is advisable that to control the operation of the register with D inputs rather than controlling the clock in the inputs of the flip flops. Okay. So now let's summarize how the register works. So here you can see that basically 3 operations can be done. One is loading, another is clear, and another is hold. Now what is the loading operation? That is pretty simple. So we can load the data. We can load the parallel data into the flip flop in the registers. Okay, and that is possible when the load input is 1. Okay, when the load input is 1 and the data in the 4 inputs, load in the parallel inputs, are transferred into the register with the next positive edge of the clock. Okay, and when the clear is 1, when the clear is 1 but load is 0, then it is irrespective of the clock. So it is asynchronous. So irrespective of the clock, it will make the flip flops clear or make the register clear. Okay, and what is the hold operation? So hold operation is that when load is 0, clear is also 0, and it will retain its states, retain its previous state, but whatever value is stored, it will just retain that, and you can read that out also. Okay, so you can see that the loading is basically dependent on the clock edge. Okay, so if load is 1, load input is 1, then in the next positive edge, the clear is in the next positive edge, the clear will be the next positive edge, the data will be stored. But clear is simply the clear input is simply because clear is asynchronous, because it does not depend on the clock input. It simply clears the register or the flip flops. Okay, so this is the basic operation of register, that is a data storage, binary data storage element in any digital system. We will discuss the shift registers and its applications and different types of shift register in the next lecture. Okay, so that's all for this video, and if you have any doubt, please let me know. And okay, so that's all. Bye.